Alrighty. The last thing we're going to do in this foldable is solving two-step inequalities with negative coefficients. So again, we're going to continue solving by showing all steps. We're going to check our solution and graph our solution set. And we've got a little hint here. Don't forget to flip the sign when needed. It is needed when we multiply or divide both sides by a negative number. The important thing that we notice here is that when we do it to both sides, that's what's important here. So solving two-step inequalities, negative 2x plus 10 is greater than 4. I'm going to try and isolate my variable term by using inverse operations. The inverse of adding 10 is subtracting 10. And if I do it to one side of the inequality, I'm going to have to do it to the other. 4 minus 10 is negative 6. 10 minus 10 is 0, so that cancels out, and I'm left with negative 2x is greater than negative 6. And then the inverse of multiplying by negative 2 is dividing by negative 2. And if I do it to one side of the inequality, I must do it to the other. When I multiply or divide both sides by a negative like I did here, my inequality symbol needs to flip, so I'm going to do that first. A negative 2 divided by a negative 2 is a positive 1. 1 times x is just x. And negative divided by negative is a positive, and 6 divided by 2 is 3. So in this situation, x is less than 3. When I graph my inequality, I'm going to graph 2, 3, 4 with an open dot on 3 because x cannot be equal to 3. It's only less than, so I'm going to shade towards the left, towards the smaller number 2. And all of these numbers less than 3 should make this inequality true. So if we wanted to check our answer, for example, we could pick negative 2 and plug it in for x, because negative 2 is definitely smaller than 3. We would say negative 2 times negative 2 plus 10, is that greater than 4? A negative times a negative is a positive 4. Plus 10 is greater than 4. 4 plus 10 is 14. And because 14 is greater than 4, our check makes sense, our answer seems reasonable, and our graph is good to go. On number 6, we've got 12 minus 4k is greater than or equal to 12. Remember that this subtraction symbol we need to read as a negative. We can't just forget it. We need to read it as a negative, or we can, in my room, we use copy, change, or keep, add the opposite is what KAO stands for. Keep, add the opposite. And so we do need to recognize this is a negative 4k. 12 plus negative 4k is greater than or equal to 12. The inverse of positive 12, because I'm trying to get this term by itself, is negative 12, and so I'm going to subtract both sides by negative 12, or subtract both sides by 12. 12 minus 12 is 0, those cancel, and here's where it's really important that we just keep the negative with the 4k. Negative 4k is greater than or equal to 12 minus 12 is 0. Now I have to divide both sides by negative 4, because the inverse of multiplying by negative 4 is dividing by negative 4. When you multiply or divide both sides by a negative, your symbol must flip, so I'm always going to do that right away. Negative 4 divided by negative 4 is positive 1. 1 times k is k. And 0 divided by any number is always 0. So k is less than or equal to 0. When I plot that on my number line, I've got negative 1, 0, 1. I've got a closed dot on 0 because it's saying that 0 could be a solution point, or any number less than 0. So I can shade to the left, fill in my arrow, and I'm good to go. When I check my answer, maybe I'm going to start with 0. 12 minus 4 times 0, is that greater than or equal to 12? Well, 4 times 0 is 0, so 12 minus 0 is 12. 12 is greater than or equal to 12, so that checks. I could also check another number smaller just to make sure that I shaded the right way, because all that's saying is yes, 0 should be filled in. I could also check, let's say, negative 1. 12 minus 4 times negative 1 is greater than or equal to 12. 12 minus 4 times negative 1 is negative 4. 12 minus negative 4, we copy, change, and we get plus a positive, or add the opposite. 12 plus 4 is 16, and 16 is also greater than 12. So my check works out. It makes sense. My graph makes sense that k is less than or equal to 0, with my closed dot on 0 shaded to the left. And so when we solve inequalities, we always want to show all our work. We can always check our solution, and we will graph with an open or closed dot depending on the symbol. Remember that the biggest hint to remember when we're doing all of this is that when you multiply or divide both sides by a negative, you must flip your sign, your inequality symbol. That's the biggest difference and the biggest rule to remember that's different from equations, because equations, the equal sign just stayed the same. In inequalities, the symbol stays the same, goes the same direction, unless you multiply or divide both sides by a negative, and then you flip your sign. Or if you want to change the order of things, remember that we could always write 3 and x in the opposite order. And then we would also want to flip our sign, so it's always opening up to the 3 no matter which way it's facing. So those are the only 2 times that we flip our inequalities: when we're trying to rewrite an inequality we've already have, or if we multiply or divide both sides by a negative.